Good morning. Welcome to episode number 47 of the ZoomTown experiment. Today we're just going to go over some updates of the overall experiment. I've also got a couple of ideas I'm going to throw at you and see what your thoughts are on these kind of weird ideas. They're kind of crazy, but they work well, I think, within our experiment. So let's take a quick top-level overview of what we're going to cover today. I'm going to mention quickly what my viewpoint is of the Pico 2. We will go over some of the serious, outstanding issues. One of them is really a pain. We will cover the very extensive master to-do list. There's a lot of work left to do. I want to talk a little bit about how I want to utilize the scheduler as another sensor. And finally, I've come up with a rather novel traffic control system idea that would work with one of the software Python extensions I'm using to create the scheduler software. A question has come up about utilization of the Pico 2. A number of reasons why I really don't need to do that right now. So far I haven't hit a limitation with the Pico W that we're currently using. Second, the Pico 2 doesn't have Wi-Fi yet, and I definitely need Wi-Fi. Now I can go with the other versions of it by other suppliers that I believe have incorporated Wi-Fi, but I'd prefer not to go down that road at this point. And then on top of it, there has been a reported issue. I don't want to call it a bug or a problem. It's just an issue that I have been following closely, both on the Raspberry Pi forums and in other websites that, like mine, that we cover Raspberry Pi products. Something to do with latching up or latching on an input when it's used in a certain specific way. And I really don't want to go down that road and introduce new problems to the experiment at this time. Now let's take a look at some of the outstanding issues. I've been experiencing a random freeze-up of the Zoomy software. What its behavior is and how it presents itself is this. I'll be over running experiment after experiment, having the Zoomy travel around from destination to destination. And then if I just let it sit for a while, suddenly it stops working. And based on its behavior, as you may have seen when I'm running the Zoomy around, I have a LED blinking on and off, either red or green. And that's kind of like a heartbeat signal. If it's doing that, I know everything is okay. But after sometimes, randomly, it sits for a bit and then it just stops blinking, the light stays on. Now, what's causing that? I have yet to track down. I suspect I'm going into some, we'll call it a loop, where I need to do something and it's not happening. And the most likely culprit could be MQTT. So that's one that I've got to watch and I have to resolve, because so far what's proven the experiment, I can get a Zoomy to go for maybe 10-15 minutes and then just suddenly it stops. But it does seem to stop when it's just sitting idle, parked in a driveway. Poor positional updating in certain areas of ZoomTown. I suspect this particular issue has to do with when the Zoomy backs out of a driveway and aligns with the road it's going to travel on, or when it turns off of one roadway onto another. That isn't always perfect. And I think what's happening when it backs up, the most typical cause, when it backs up, it looks for that. If I'm coming into the middle of a road, if I back up, it looks for a set position magnet. If it doesn't see that, then its positioning system is off. I believe that's where the problem is, but what I have to do is get it to happen consistently in certain areas. And of course, I got a lot of film equipment here that I'm usually just recording, and not all that footage you guys see. And then I can study it to see what's really going on with that. But that could be another major issue. Just needs to be studied further so I can understand it to develop a solution for it. Deceleration is not being performed in every area, and I know the cause of that, and there were certain areas many months ago where deceleration to a stop as opposed to just stopping was causing problems, and in all likelihood I fixed whatever was causing that, so now I got to get things back into a behavior that I want, decelerating and accelerating as opposed to instant start and instant stop. So nothing really over complex, just needs to be understood and a proper solution developed. Moving on to the master to-do list. I like to-do lists because I like checking off things as they're complete. But right now, looking at this to-do list, oh my goodness, there's a lot of stuff on here. So we'll go over that real quick, and you can kind of maybe share in some empathy how much more work we've got to do to get to the real experimental phase of the ZoomTown experiment. Most of this is around new code development. Now, the first one is probably the most complex, and it's one I've been studying a lot and doing some testing with. The check for clear to proceed functions. As you can imagine, there's areas where I have to stop, check for clearance before I move across a traffic lane or multiple traffic lanes, etc. You don't want to pull in front of a car in cross traffic and get hit, all sorts of things like that. Now, seemingly, especially a year ago, a little more than a year ago, when I'm conceiving this whole experiment, I thought it would be easier than it is. Well, I'm discovering the checking for this is far more complex than I wanted it to be or expected it to be. So that one is going to take a lot of work to resolve in a good way. But I got an idea on that one I'm going to throw at you a little bit later in this video. I need to develop a random time generator, and this would be used for delaying, say a Zoomie just parks in a driveway. I want it to wait a random period of time, probably a couple minutes at most, and then it would take off and go to another destination. Truthfully, it's a rather simple task, but it has to be done. Coupled with that, I need a random destination checker. I need to go to random destinations, and I want that to be as random as I can get it, and that might even be doing a double randomizer type thing to get it truly random. I also recall recently seeing a true random function that was somebody had for working with MicroPython, so I might even go hunt that down and run some tests on it. But I do want it to be fairly robustly random. Reservation system. The concept of this is at any time I know if a driveway is currently occupied or empty. So that means I could take any destination that's occupied, assign that Zoomie to go to an unoccupied destination, empty driveway. But while it's in that travel, it is neither occupied or empty. So that's where I need this reservation system. So in other words, the Zoomie is in a driveway occupying that destination. As it's traveling, I've reserved the destination that I'm going to. And that way the random path and trip generator can't use that spot that this Zoomie is going to. Then when it finally arrives there, we would reflag it as occupied. So that needs to be developed. Frankly, I think it's going to be nothing more than a list of lists with 3 elements per line. and that would tell us whether the driveway is occupied, empty, or reserved. Banned destinations is an unusual one in that there are certain areas where I don't want the Zoomie to go from one location to the other. And very specifically, it's in the area on the left end of the layout where one driveway is straight in line with the driveway on the opposite side of the street. The positioning maneuvers on that are very simple. Literally, we back out of one, turn, then pivot turn and pull into the next. But it creates other issues that will add complexity to the experiment, and I don't really think we need to have that. So I just want to ban certain destinations to go from one location to certain destinations. And there may be, this might also help me if I get into certain areas on the layout where for whatever reason I just can't get good behavior in that trip, and then that way I could ban it as well, and it won't have to be recoded out or everything special coded for, well, if you go from this destination to that one, don't do this if that, and all that crazy stuff. So this ban destination functions should be, again, very simple because it's just basically a hard-coded list, but I need to think through that as well. This next one has a major impact on the overall scheduler software. If you've been following along, especially these past few months, I had started out at the beginning using a path planning algorithm. The most common one, I believe, is probably Dijkstra. And what it does is, given a starting point and ending point, it will find the shortest way through. And I've used that with other robotic projects years ago, and I only learned of it for navigating from point A to point B, shortest path. Luckily, one of our viewers, Tomek, he explained to me that you can play tricks with that and have it avoid certain areas as opposed to only going shortest path. And once he got me to understand that concept up, it opened up a whole new world of what this experiment could be about. So with that, I'm going to re-implement it. Now, I asked a few, probably a month ago, if there were volunteers that would help me in manually programming all these trips. This would eliminate the need for that. I very much appreciate you offering to help, but it would eliminate the need for that, and it would give us much more capability with the experiment. It would be far more random in this with the utilization of the Dijkstra shortest path algorithm. So that's got to get reincorporated. I don't think it's going to be very difficult because the process for all of that I developed a very long time ago would almost be identical, so I just got to incorporate it but use the new data types and data formats that have since changed. I need to correct or finish coding certain sections where a function or a feature, a capability was developed with just thinking about one Zoomie. It just made it very simple to do because then I didn't have to build a list of Zoomies, iterate through that list, etc. So when I would develop it, I just had the one Zoomie that I'm currently experimenting with, and then I would send that off to do some task. Well, now I need to polish some of those so that it can handle all 16 Zoomies. Again, not complicated. It'll be tedious programming, and I can't really test it until I get all the Zoomies. So I got to spend a little extra time testing it, not hacking my way through it, hoping it works. If you've observed closely, you'll notice that in the scheduler software, I don't yet have a start experiment, meaning I got everything there, and currently I can do one manually program a trip, hit cycle start or the green start button on the operator panel, and it'll take off and run. But when we go to run experiments, I need an official way to actually click something, probably an on-screen button, that would start the experiment running, where the randomizer would go through, pick a time, pick a location, pick a Zoomie, and then send the instructions to it, and off it goes. And then that whole process would keep repeating. And it would run open-ended until, going back to our to-do list, the end experiment function would then have all the Zoomies just finish up their last trips, and then the system would stop running. Those shouldn't be too difficult. I actually already had something functional in there, but have since taken that code out because I was changing so many other things. So I need to get that back in there. I have 14 other Zoomies I got to finish assembling. I've got the bulk of the hard work done with the soldering of the circuit boards, getting a lot of the jumper wires cut to length and the ends terminated, etc. But now I got to bring all the components together and then, of course, test them for all the sensors, functionality, and all of that. And that can be a very time-consuming process. It's not very difficult. The assembly's rather simple, but if you test it, you find out, oh gee, that motor driver little circuit board doesn't work, well, you got to take the whole thing apart, replace that, because some of these are inexpensive components that may or may not function when you buy them. I expect that. I bought extras for almost everything with that expectation, so it's just work and tedium to get through. This last one on the master to-do list is to develop and refine the scheduler as a sensor functionality. Now, a lot of the discussion we've been having on the scheduler so far is it figures out where the Zoomie should go and tells it to go. And that's its been primary thing. I've added in position tracking, and I'll have a video coming out on that here very shortly, probably a week, maybe 2 weeks out from when you see this, which should be October 1st. I'll be posting this video. But as you know, the Zoomie is limited in what it knows, and I need to give it as much information as I can so that it doesn't crash into things. So let's take a look at a little bit more detail of what I'm talking about with this idea of using the scheduler as a sensor. The Zoomie is very limited in what it knows about its surroundings. Essentially, it is totally blind with the exception of the cast sensor. It does use the TCRT 5000 photoreflective sensors for line following, but that just guides it. I have additional sensors, 2 Hall effect sensors that detect magnets in the road that help with position and distance tracking. I have encoders on the wheels, 2 of those, 1 on each wheel. That helps with position tracking. But other than the cast sensor, which only sees directly in front of the Zoomie and not for its full width, it's a cone-shaped sensor in its emission pattern and what it's seeing in return. So the robot Zoomie is very limited in what it knows about its surroundings. So it could very easily, if a Zoomie is coming at it from an angle, such as around a turn, it could drive right into it. So I need to come up with more ways of giving the Zoomie information. Now the Zoomie, it can, however, communicate with the scheduler and get information, and very important information from it. It has knowledge of where all the other Zoomies are, and it has fairly accurate knowledge of that. That is something that still needs to be refined, but right now I'm probably looking within maybe a ½ inch, maybe a little better, knowledge of where each Zoomie is. I wanted it to be a ½ millimeter. I really don't think that's going to happen anymore, but I'm getting it better and better. But with the scheduler knowing where the zoomies are, I can then use the scheduler as a sensor for proximity from zoomie to zoomie. And I can start making logical decisions whether or not I can go on making a turn and that sort of thing. Now, the scheduler software has another feature built into it because of an additional library that I'm using with it, and that I'm going to talk about here in a moment. But anyhow, when we get back to this idea of it being a sensor, there is information there, and I can get that information from it very much in the way that I do information from the encoder, from the collision avoidance sensor, from the Hall effect sensors, from the photoreflective sensors. I just ask those for information and it gives it to me. And I'm going to treat the scheduler the same way because it too has information I can use. Thus, we will treat it as a sensor, a vision system, if you will. That is the subject of the next videos, or one of the next ones coming up. Now I want to talk about this novel traffic control system. This is an idea that just kind of came at me when I was trying to figure out all the rules of the road where the zoomies can hit each other, and trying to develop logic to deal with that. Now, one of the simplest things, everybody will say, well, if you know where all the zoomies are, just measure the distance to each zoomie. Absolutely. But the problem with that is I need to be concerned about what's in the near proximity and on the road that I'm currently, say I'm the zoomie turning left. Well, I'm worried about who's in front of me that could drive into me as I turn left, or who I could drive into. And it starts getting really complex because sometimes I can only, from the place I'm turning left to the end of the road, might only be 2 inches, 50 millimeters. Well, in the time, approximately 3 seconds it takes for me to start the turn left, cross the oncoming traffic lane, and then continue moving far enough so the back end of the zoomie is out of that traffic lane, that's 3 seconds. At 8 inches per second, the oncoming zoomie can come at me from 24 inches away. That's a long distance. So I have to look forward in time to understand all this, and that could be literally multiple turns of a zoomie to trace its starting point and how it would get to us. It gets very, very complex. A lot of fun, but holy cow, my brain just wants to blow up when I keep thinking about it. But back to this novel idea. Rather than have to rely on all of that knowledge, the idea was this. If instead of having actual stop signs to stop all traffic all the time, what if there were stop signs that were only activated when needed? Now, we can think about that in modern transportation and traffic systems. A lot of traffic lights today, at least here in the U.S., are controlled by sensors either embedded in the road, or now a lot of them are up on the traffic light masts that hold all the lights up there. And they detect if cars are there waiting to enter the intersection. If there's nobody there, the light never turns green. So it just kind of keeps traffic flowing. So it's a concept similar to that. Now, what I'm thinking, what if I had an imaginary shield around the car that is making the turn? Say it was a shield that would be 4 inches, 100 millimeters forward, 100 millimeters back, 100 left, 100 right. Just this bounding box that nobody else can enter. If I have that and I can put it anywhere, I can then put that down before I make the turn. Now I'll go over here at the layout and I'll demonstrate that so you get a visual idea of my concept. I've set up a few of the zoomie bodies here to help explain what I'm thinking of, because it is difficult to conceptualize. Let's say zoomie number 1 wants to come up to this point, turn left, cross the traffic line, get to the start of the next line, and then it has to get to this point before this zoomie can pass through. Furthermore, once the zoomie turns to here, and if there's a zoomie behind it, if it gets to about this point, the cast sensor won't see that, and it could hit it and cause a crash. So my idea is this. Now this won't happen on the physical layout, but conceptually I can do this in the scheduler software. If these two zoomies here, number 1 and number 6, are traveling that way, and A could be literally all the way around the corner to this location right here. And it would travel around and then could hit me broadside, right? So we'll just put him there. Now what I'm thinking is this. As I'm coming along, what if I threw an imaginary barrier there, a zone that nobody can penetrate except for, in this case, zoomie number 1. So let's see what will happen here. I'll put him a little closer. He can get into there. This one will stop because the barrier applies to number 6, but not number 1. I can do that in program. So that's there. Now this zoomie, once it gets to this point, to turn left, it stops and it checks to see what's going on. It'll ask permission from the scheduler, this computer, if it can go. Well, the scheduler would place down this barrier, and if nobody is currently within a certain distance, this zoomie could start the process of turning and traversing across. In the meantime, this zoomie's coming along, it hits that imaginary barrier and stops. When the zoomie here gets to some point here where the back end of it is clear of the zone, the zoomie tells the scheduler, or the scheduler already sees it, that this is in the clear. It removes the barrier, allowing traffic to continue. Pretty wild idea. A little bit of craziness is going to have to go into making it work, but I think it's an interesting concept, well worth exploring. Now hopefully that gives you a little better idea. Now we'll just finish up with my discussion here, and we'll bring this video to a close real quickly. So if I've got that imaginary shield, I can prevent other cars from getting too close, and I can put it down only when needed. And this is where the gaming technology may solve a problem in a new and novel way in how I'm utilizing that gaming technology to my advantage. And that we'll get into in a couple of videos, I think, total. And it's going to get very interesting, at least in my perspective, because it's a completely abstract and different method of controlling traffic that we can't use in the real world, but we could. Last thing we'll talk about real quick is our filming and production schedule. I want to continue right now with every other week for our big videos, the ones where I go into some detail about a topic. I got a lot of work to do on each one, and I'm going to juggle through that, the remaining ones, as efficiently as I can in an effort to not slow down production, because I need to keep this project moving forward to move on to other video production projects. So every other week will hopefully be a more in-depth video, but I'm also going to try to do some of the smaller topics that might be able to be covered in a 5 or 10 minute video. try to film those and get that out at some random time between that 2-week interval. Kind of like how these update videos have been happening. It's when I get time to sit down, organize my thoughts, do them up, and then put them up on the next convenient day. So based on this somewhat regular and somewhat random schedule, now might be a good time to turn on notifications by clicking the notification bell, and then that thing will help notify you when I throw up videos, etc. So with that, I think we'll wrap up this video now. It ran quite a bit longer than I originally intended, and hopefully you enjoyed it. And hopefully I've got your interest peaked a little bit for these upcoming next series of videos that'll bring us to the end of development phase and take us into experimental phase. Thanks again for watching, and I look forward to seeing you in the next video.